Hey, this is your short video on non-probability sampling, and as you heard on previous videos, non-probability sampling should be used only when probability samples are not an option. So non-probability sampling is a technique used to collect samples without the use of probability theory, right? Samples obtained with non-probability sampling are very likely to be biased. So non-probability sampling should only be used when probability sampling is not an option, right? A rule of thumb you can use to know if a sample is a non-probability sample is that when you select the subjects, you have a non-probability sampling sample. When the subjects select themselves, you have a non-probability sample, right? It's only when a random number generator selects the sample that you have a probability sample. Otherwise, you have a non-probability sample, right? And non-probability samples are biased, and they remain biased regardless of how large the sample is, right? Bias is not a function of sample size or of sample composition, as we discussed in the previous video, but it is a function of how the sample is selected, right? It's the sampling method that makes it biased or not. However, there are some situations when you have no other choice but to use non-probability sampling. And one of those is when you don't have a sampling frame. Remember that for probability sample, you need a sampling frame. But in some cases, you don't have one. So you have to use non-probability sampling as a last recourse. We're going to discuss 4 types of non-probability samples. The first one is the convenience sample. That's the most commonly used. Then you have the judgmental sample, the respondent-driven sample, and quota samples. So let's start with convenience sample. It's a type of non-probability sample where the sample is drawn from a part of the population which is close to hand, right? The sample is readily available and convenient to use, so you select that group from the population. This is also known as accidental sampling or opportunity sampling. Right, so let me give you an example. Suppose I want a sample of CHHS students. So which ones should I select, right? Suppose I don't have a sampling frame, and the most convenient sample in that case would be to choose you, right? Students in 385. I would choose them. I see them every week. It's really convenient. But now, beyond all the ethical implications of me doing that, which you should know that it's not the ethical thing to do, this sample is biased, right? It's biased because the students are not representative of the entire population. It's a convenience sample, right? And convenience samples are very common out there. Most of the people doing surveys use convenience samples. So I had many students have done papers here, and they all used convenience samples, and city officials, cities, offices use convenience sample as well. So they get biased samples, right? So in one case, a student wanted to sample CSUMB students, right? So she surveyed 100 students she found at Pete's Coffee, right? She stood at Pete's Coffee and distributed surveys to 100 students. Now, that was convenient, right? But that sample was non-representative, right, of the entire population. Let me give you another example here. The mayor of the city of Marina wanted to know if Marina residents are happy with the services the city offers. So he surveyed 500 people in the Marina Library. Right, so he surveyed the first 500 people that went to the Marina Library. Now, this is a convenience sample, right? He surveyed just the people in the Marina Library because, you know, they were there. And the Marina Library is a city service, so people at the library work for him, so they couldn't say no. Now, is this a representative sample? Really, it is not, right? Because the 500 people you find in the library are already using a city service, and they're probably already happy with it, right? Otherwise, they wouldn't be at the library. So that is a bias sample. In another example, suppose that I wanted to survey 200 CSUMB students. So I placed some posters all over the school and asked for volunteers. Please volunteer. You know, I'll give you a target card. Come and fill up a survey. Come to 86D, and I'll give you your survey. The first 200 students are selected. Now, is that a bias sample? Well, it is, right? Students selected themselves to participate in this sample. So it's convenient for me, but those students may be different than the rest of the students in the population, so they may not be representative of all the student body. Now, second type of non-probability sample is judgmental sample. And on this one, you don't choose based on convenience necessarily, but the researcher chooses based on her or his best judgment, right? The researcher thinks he or she knows who the most representative subjects are, and he or she chooses them because they are, you know, the representative individuals from the population. This technique is also known as purposive sampling. And it is usually used when there is a limited number of subjects that have special knowledge in the area being researched. Right? It's not that common, but you'll see it around. And it's a non-probability sample sampling technique. Now, respondent-driven samples, under this type of non-probability sample, the researcher chooses a few subjects and then asks those subjects to choose others, and those others choose others, and so on. That's why this is called, also known as snowball sampling. And this is an interesting, technique, and it may be the only way to collect samples when the populations are secret or are hidden, right? So for example, imagine that you want a sample of CSUMB students who use cocaine. So your population is all cocaine users in CSUMB. Now, you're not going to find a sampling frame of that. There won't be a list of all cocaine users, right? But you may know one or a few. So under respondent-driven sampling technique, you would give your friends, or the ones who you know use cocaine, surveys, right? So they would fill the survey, and then they would give surveys to their friends who they know use cocaine, and those friends will distribute their surveys to their friends, and so on. And they will all mail the surveys back to you. And you will get a sample of that. Now, is that representative? You don't know, right? You would never know because you cannot observe the population. But it's the only way to get a sample of this secret population. Under a fourth type, quota sample, the researcher chooses some characteristics of the population and makes the sample representative of the population on those observable characteristics, right? So the researcher chooses elements based on some observable characteristics of the population to make the sample representative in terms of those observable characteristics, right? Now, the sample will be representative in terms of those observable characteristics but not on all characteristics, right? Now, you need to be aware of this because they may seem representative, but they are not representative in all characteristics, and that's what we want in a sample. Let me give you an example of that. So, suppose we have the population of CHHS students, and we need a sample of 10 students, right, from that population. And we want that sample to be representative in terms of color. So what we do is we know the distribution of color here for the population, right? And now my sample has to have the same composition as this population in terms of color, right? So my sample would need to be about 65% orange, about 9% green, about 22% blue, and about 4% pink, right? So, and that's what I did, right? I chose, and this is key, I chose elements based on their color to be sampled. And I got 7 orange, 1 green, 2 blue, and 1 pink, right? So this distribution in my sample is pretty close to that of the population. So this sample is representative in terms of color, but not in all characteristics, in all other characteristics, right? Just in terms of color. Now, you may remember stratified random sampling in the previous lecture. Now, what makes this different, right, is that here I'm not really dividing the population in strata by color and then randomly selecting them, right? That would be a probability sample. In quota sampling, I am choosing the subjects to be sampled. So I'm using convenience sample, let's say, based on color, and that's what makes it non-probability. And you need to be aware of this because they may seem representative. A lot of some quota samples are representative in terms of several observable characteristics, but it is this non-observable characteristics or unobservable characteristics that make it biased. So beware of those. The only way to have samples that are representative in all characteristics is by using probability sample, right? So every time you use a non-probability sample, you have to disclose that this sample may not be representative of the entire population, right? If you want to get precise results about the population and make inferences, you should not use non-probability samples. But there is a place for non-probability sampling in research, right? When you're doing some type of exploratory research, or when you're doing research with hidden populations or populations where there is no sampling frame available, you will use a non-probability sample. And there is a place for those in science, right? But this means that you need to be very aware of the type of sampling method that we use to collect a sample. Whenever you read some results, you should first look at how the sample was selected, in order for you to know if the results are representative or not. A lot of the internet surveys that you see, a lot of the TV surveys that you see are convenience samples and therefore non-representative. Alright, so that's it. Thank you very much for watching.